Our first example involves us imagining us at a build-your-own-burrito bar. Here, to build your burrito, you need to choose white or brown rice, a kind of bean from two options, or choosing no beans, choosing a kind of main filling, of which there are 4 options, and lastly, to choose a kind of salsa from 3 levels of heat. The first thing we might realize is that we need to make some choices about kinds of rice, kinds of beans, kinds of main filling, and kinds of salsa. Because these aren't presented as alternatives, but one thing that we do after another, we get this notion of steps. And I'll leave some space while I write these out. In the context of rice, we see that there are white or brown rice to choose from. So our first alternative is white rice, and our second alternative is brown rice. Here the amount of options for this alternative 1 and alternative 2 is each just one option. For beans, our first alternative is to choose some kind of bean, and we're told that there are 2 kinds to choose from. Or we could choose no bean. This counts as a third option. For this main filling, we're only told about 1. For the main filling, we're only told about 1 thing to choose from, but we're told that there are 4 options for it. And for salsa, again, we're not told much more than there being 3 options to choose from. At this point, we've set up the decision algorithm, and we can try to work outwards to set it up. Our 2 alternatives for rice gives us a total of 2 rice options. Our 2 alternatives for beans give us 3 options for beans. Our 1 alternative for main gives us 4 options for main, and our 1 alternative for salsa gives us 3 options for salsa. At this point, we can work on our outermost layer. We have steps, which tell us multiply. We have 2 times 3 times 4 times 3. Altogether, we find that there are 72 ways to build a burrito. Our second example has us consider 4-character long pins, and we're told that either the pin is 4 digits with no restrictions, or a lowercase letter followed by 3 non-repeating digits. As we build up our decision algorithm skeleton, it can be useful to picture our potential pin. Our pin could look like 1120, or it could look like A137. To choose how we want to fill it out, our first answer that we'd need to come up with is, do we want it to be 4 digits, or do we want it to be a lowercase letter, then 3 non-repeating digits? In the realm of the decision algorithm, these are 2 alternatives. Thinking more deeply in our first alternative, the scenario where we chose a 4-digit code. First, we chose what's in the first slot, and then we chose something in the second slot, and then something in the third slot, and then something in the fourth slot. Those and thens clues us in that these are steps. The number of ways to choose a digit for our first slot is 10, and for our second slot, 10, our third, 10, our fourth, 10. We can similarly think about this for our alternative 2. Our first step would be to choose a letter, of which there are 26 to choose from. Our second step, choosing what's in our second slot, is to choose a number. Here there are 10 digits to choose from. Our next step, filling in that third slot. Here we have this additional restriction of these digits being non-repeating. So whatever we do, we have to choose a number, but not repeat. This means there are only 9 options to choose from, all of them except for the one that's already been chosen. Lastly, we have to choose for our fourth slot. Again, we have to choose a number, but we want to avoid a repeat. So at this point, we can't choose what was in our second slot, and we can't choose what was in our third slot. We only have 8 things to choose from. Here we have our skeleton filled out. So now let's try to work outwards, counting each layer. We have steps, so 10 times 10 times 10, which is 10,000. And we have 26 times 10 times 9 times 8, which is 18,720. And then our outermost layer, we have 2 alternatives. So we'd want to add 10,000 to 18,720 to get that. There are 28,720 possible pins.